Hi everyone, welcome to Psychological Research, UNISA PYC 3704. We're going to start with just the key terminology. This is one of those units you have to spend a lot of time yourself going through everything because of the math, and the math is like a language. You have to learn it repeating. So I'm looking forward to experimenting with different ways of presenting that for us, because it's time for me to start revising, and the best way for me personally to do that is to do another YouTube video. I hope that this time I can take the course right to the end. Work and other demands on life permitting. So good luck to everyone. Let's get started with key terminology. Okay, scientific process. The scientific process is a systematic approach to gaining knowledge through observation, experimentation, and analysis. It involves forming hypotheses, testing them through experiments or studies, and drawing conclusions based on evidence. Theories are organized explanations for phenomena based on observations, experiments, and analysis. They help us to understand why and how things happen as they do. Statistical inferences. These are when you make predictions or draw conclusions about a population based on a sample. It involves using data from a smaller group to make generalizations about a larger group. Okay, theorizing is the process of forming theories or hypotheses to explain observations or phenomena. It involves proposing possible explanations and then testing them through research or experimentation. Quantitative methods. Quantitative methods are research techniques that involve collecting and analyzing numerical data. Quantitative methods use statistical analysis to understand relationships between variables. Constructs. Constructs are concepts or ideas that are measured or observed in research. Constructs are abstract and may not be directly observable, so researchers use operationalization to define how they will measure them. Okay, operationalization is specifying the procedures or operations used to measure abstract concepts. So it's a way of turning thoughts, ideas, hypotheses into numbers that can be measured. Measurement quantification is the process of assigning numbers to observations or variables to quantify them. So this is what happens when you operationalize something, okay? So that you can compare and analyze data objectively. Variables are factors that can change or vary in a study. You get independent variables, which is the factor being manipulated, and dependent variables, the outcome being measured. Like, for example, if you ask a group of male colleges, if you send out, okay, let's say you're setting up an experiment to see what response people have to being sexually propositioned. You could set it up to have an older female person approaching men and sexually propositioning them and seeing what percentage say yes, and then a younger female person doing the same. So your dependent variable would be the amount of men that say, oh yes, great idea, and the independent variable would be the woman and her age. Okay. Probably a Freudian slip coming up here, hey? Okay, so data. Data is the information collected in research studies, which can be numerical or qualitative. Data is analyzed to draw conclusions and make inferences. Descriptive statistics. So we've looked at inferential statistics. Now we're looking at descriptive statistics. These are statistical methods used to summarize and describe the characteristics of a data set. So it's like standard research methodology is descriptive statistics. So this is the mean, the median, the standard deviation, and so on. Okay, populations and samples. Population is the entire group of interest in a study, while samples are subsets of the population which you identify and use for research. So sampling involves selecting a representative group from the population for study. Parameters and statistics. Parameters are the characteristics of the population, while statistics are characteristics of the sample. Statistics are used to estimate the parameters from the characteristics of the sample. That is inferential statistics. A test statistic. That is the value calculated from the sample data. So it's the statistics relating to the actual test you've done. Okay. Compared to probability distributions to determine the likelihood of obtaining certain results by chance. So you're looking at, well, if it was just chance, what would our results look like compared to the results we actually got? Okay, parametric statistics. These, when you make assumptions about the population from which the sample is drawn, usually involving the distribution of the data. So for example, when you assume that the heights of students in a school are normally distributed, and then you use the assumption to perform a t-test to compare the heights of students from two different classes. Okay, non-parametric statistics. This is when you don't make any assumptions about the population from which the sample is drawn. So you make fewer assumptions, and are often used when the data do not meet the assumptions of parametric tests. Huh? Okay. Okay, so for example, using a test, a rank test, to compare the median scores of two groups without assuming that the data is normally distributed. All right. Error component. This is the discrepancy between the observed values and the values predicted by a statistical model. So because there's always going to be some error component because statistics are not about certainties, but about probabilities. Okay, so for example, in a linear regression model, predicting a student's exam scores based on study hours, the difference between the actual exam scores and the scores predicted by the regression equation is the error component. So it doesn't necessarily mean that you've made a mistake. It just means that this is reality compared to what you would predict would happen. Okay? The research process. Okay, the research process. A systematic series of steps taken to gather, analyze, and interpret information to answer particular questions or solve a problem. For example, conducting a study to investigate the effects of a new teaching method on students' academic performance, including designing the study, collecting the data, analyzing the results, and drawing conclusions. Statistical and operational hypotheses. Statistical hypothesis, a statement about the relationship between variables that is testable using statistical methods. Operational hypothesis, a statement that specifies the procedures or operations used to measure or manipulate variables in a study. For example, a statistical hypothesis, there's a difference between test scores between students who received tutoring and those who did not. An operational hypothesis, students who received tutoring will have higher test scores compared to those that did not. Okay, you measure it by looking at test scores. And you measure it by looking at hours of study, I presume. That would be operational. Okay, classical, frequentist, and subjective probability theory. Let's start with the wishy-washy. Subjective probability theory. probability based on personal judgment or beliefs. Okay. Then frequentist, you measure the frequency of occurrences of an event in repeated trials. And then classical probability theory is when you work it out mathematically, such as the probability of rolling a six-sided dice and getting a 3 is 1 in 6. For each side of the dice, there's a 1 in 6 chance. Okay. Sample space. This is the set of all possible outcomes of an experiment or random process. For example, when rolling a six-sided die, the sample space is 1, 2, 3, 4, 5, 6. Law of large numbers, and that's written in brackets with comma. 1, 2, 3, 4, 5, 6, in brackets, that's the sample space. The law of large numbers. The law of large numbers states that as the number of trials in a random experiment increases, the observed outcomes will converge to the expected value or true probability. So the more often you flip the coins, the closer the proportion of heads observed will approach 0.5. Gambler's fallacy. The mistaken belief that if something happens more frequently than normal during a certain period, it will happen less frequently in the future, or vice versa. So when you haven't thrown a 6 for ages, you're going to start thinking, okay, it's time for a 6 to appear. Okay. Probability, the numerical value representing the likelihood of an event occurring, typically expressed as a fraction, decimal, or percentage. For example, the probability of rolling a 6 on a fair six-sided dice is 1 in 6, or approximately 16.67%. Definition, a measure representing the size or amount of one part relative to the whole. Proportion, yes, sorry, not definition. Proportion. I was like, what? Okay, proportion is the measure of the size or amount of one part relative to the whole, such as if half the students in a classroom of 30 are boys, then the proportion of boys in the class is 15/30 or 0.5. Range. Range is the difference between the highest and the lowest values in the data set. So for example, in the data set, open brackets, 3, 5, 9, 12, 17, close brackets. The range is 17 minus 3 is 14. That is how big the gap is between the biggest number and the smallest number. The highest and the lowest value in the data set. No probability and the sum of probabilities. Okay. The sum of probabilities. Again, null probability, the probability of an event not occurring. The sum of probabilities is the total probability of all possible outcomes in a sample space, which would add up to 1. So, for example, if you're rolling a six-sided die, the sum of probabilities of rolling each number would be 1. You'd take 1/6 plus 1/6 plus 1/6 6 times, would add up to 1. Okay, that's the sum probability. Okay. All right, so that's enough terminology for now. Let's see if this actually worked. And if it did, then we will continue soon.